Hi everyone, welcome to this episode of Keipert Labs. In today's video, we're going to talk you through how to draw structural formulae from molecular compounds. So in our previous video, we were looking at this idea of actually modelling the formation of compounds and using Lego bricks and the valence model of bonding as a way to try and start explaining how this works. And so we saw that, this is as a model of the molecule CH4. Or methane, okay, where we had a 1 carbon to 4 hydrogens. And we were modelling it this way, and we kind of set down some ground rules and looking at saying, all right, that for our model that we only use 2 rows of Lego bricks, with that each pair of studs, the little bumps represented 1 connection, that all possible connections must be filled, that we couldn't have any empty spaces, or we couldn't have any leftovers, kind of extra, we couldn't kind of do kind of some connections like that. All right, so this is the way that we kind of pictured it. Now, as useful as the Lego model is, and then drawing the diagrams and getting to think laterally by building out some things, the reality is that our model needs to improve from here, that we need to have a way to represent things more scientifically, more accurately on paper, and in a way that also starts to build the nuance in how these molecules are put together, because there's only so much you can really picture with Lego bricks like this. And so what we can do is that we can translate this into what we call a structural formula. Okay, so what we can say is, all right, we can write a formula like this, and that gives us some information, but let's actually then say, all right, I'm actually going to draw connections between atoms. Okay, so we can say each connection equals a line, okay, between an atom. Okay, so we have a carbon and we have 4 hydrogens. So how about I do this? I've got 4 hydrogens around that atom. So that's kind of getting towards this idea. And I want to show that this carbon has 4 connections, 1 to each of these hydrogens. So I can use a line to actually demonstrate that connection. That looks like this. So now I've taken my lovely and tactile and very helpful model, and I've turned it into something a little bit more abstract, but that also can be quite informative. Okay, and so I've got this as a model of methane. So as a structural formula that shows the connections between these atoms. Okay, now I can do NH3. Okay, and so I can say, all right, well, I've got a nitrogen connected to 3 hydrogens. Okay, now I'm just going to choose to do it like this. Okay, and so now I've got my 3 hydrogens connected. I've got 1 line to each one, and there we go. Okay, now just want to walk you through though. There was a different kind of model where it's a little bit more complex that I can show you how the model now has some extra power to it. Here I have another example here, which has carbon, hydrogen, and oxygens together. I've made the model here so that you can see it, but I've also drawn a slightly larger version of it as a diagram over here. So we have the carbon, which has 4 connections to 1 hydrogen, 2 hydrogens, and then to an oxygen. But what you can notice here is that in this molecule, which is called formaldehyde, the actual molecule itself, is that this carbon's got two connections to this oxygen, okay, and then 1 connection each to the hydrogens over here. So how can we represent that? All right, so if we move that to the side and we start with our carbon in the middle, okay, now what we're saying is that we've got an oxygen and 2 hydrogens that go around this. So I'm just going to draw them like at a triangle kind of shape, just because I've got 3 things around that. Now, I see that I've got 1 connection to each of my hydrogens. That's what that pair of studs that represents. Now I've got 2 connections to this oxygen. And if each connection is a line, well then I can show that I've got 2 connections by using 2 lines. So this carbon's still got 4 connections, 1, 2, 3, 4. But I can demonstrate visually how those connections happen, how that arrangement happens, so that you can see very simply, very quickly, how that molecule is put together with a bit more accuracy and a bit more detail. Okay, now I'll do one last example. We'll go back to just using carbon and hydrogen for a moment. I won't use the Lego model, but it look like this. Okay, so I've got 2 carbons and 2 hydrogens. Okay, so the idea here is that I've got one connection here, and then I've got 3 connections in the middle. Okay, so I've got a carbon, and then I've got hydrogens. I've got one connection from each carbon to a hydrogen, and then I've got 3 connections in the middle. If each connection is a line, then I can do 1, 2, 3. And this molecule is called acetylene. Okay, that's what plumbers would use in your welding, welding equipment. And so what we can see is that this sort of technique of using lines to represent connections between atoms has a lot of power, a lot of versatility, and it's also, we're going to build on it a next step to actually look at the 3D structure of molecules like this. Okay, and by being able to represent them confidently like this, then we have the skills that we need for that. All right, the rest is over to you. Thanks very much for watching. Bye for now.